21b. I'd rather do them algebraically too, but a lot of times we can do them, we only can do them by graphing. Limits by graphing. Sometimes it's hard to see what the exact answer is by graphing. So here, I'll show you. All right, so remember, we're going to be given a function, and as x gets closer and closer to that value of c, it's what is f of x approaching. So the limit as x goes to c for f of x is going to equal whatever the y value is getting closer to. Okay? So something like this. Number 1, we're going to find the limit by graphing. Find the limit by graphing. Letter A. Now on the quiz on Friday, if I tell you to solve it algebraically, but you choose to solve it graphically and you don't show any work, you're not going to get credit. Half? Oof, I don't think any. The limit as x goes to 0. Sure. Sine x over x. Now for something like this would be really tough to do algebraically, right? Yeah. It's actually, you can do it algebraically using something called a sandwich theorem, but I'm on a diet, so we're not going to use that theorem this year. So we're going to go to y equals, and we're going to do, and plug it in. Sine x divided by x. Make sure you close the parenthesis around the top x. Okay, now if you try to do direct substitution, you get 0 over 0. That doesn't mean the limit doesn't exist. It means that there's something going on there. So when you hit graph, oh no, sorry, I was doing some scatter plots earlier. So zoom 6, bring me back to a normal window. And I really want to see what's happening at x equals 0. Shh, guys. So I'm going to go, just a second. I'm going to go ahead and zoom in. And it's pretty obvious, right, what it looks like. Yeah, so if I hit trace and I plug in 0, there's no value at y. There shouldn't be. Okay, it's discontinuous at x equals 0. But if I want to figure out what the limit is, because they're both approaching the same y value, I can plug in 0.00001. Or I can plug in negative 0.00001. You can plug numbers in on either side, and guess what? The limit is 1. Okay? So it looked like this. Graphically speaking, it went like this, and then it went up here, hole in the graph, and went like that. So as x was getting closer and closer to 0 from this way and that way, our y value was getting closer to 1. Now, it didn't equal 1, but it doesn't have to. A limit is what is it approaching. Approaching is like the big word. All right, let's do another one. Letter B. Let's find the limit as x goes to 2 for x plus 3 over x minus 2. Okay. Once again, there's a little bit of an issue here. Okay, nothing you can do algebraically, but when you plug in 2, there's nothing happening, right? There's no value at 2. When I plug in 2, I get 5 over 0. Well, what does 5 over 0 mean? It really means undefined, you're right. So if I plug this in, and I do parentheses x plus 3 divided by x minus 2, and I graph this, we know that at x equals 2, let me do zoom 6, there is a vertical asymptote there. Okay? So let's talk about this graph real quick. So here's what the graph looks like. It goes like this. Here's 2. And then it's up here like that. Okay? So take a look from both sides of 2. Here's 2 right here. On the left, my graph is going closer and closer to what value of y? Negative infinity. On the right, my graph, as it gets closer to 2, is going up to positive infinity. How can I be two places at once? I mean, I'm a twin, but still can't be two places at once. So this right here, you go up, you go down. The limit, as Lindsay Lohan would say, the limit does not exist. Did you ever see that movie, Mean Girls? Yeah, I see some of you smile at that. You like that movie. I don't think so. There's a clip. Yeah, nah, not today. Nah, we're good. All right, let's do one more. Now, not all the time is it going to be that the limit doesn't exist, okay, when you have an asymptote. So, for example, if we take the limit as x goes to 0 of 1 over x squared. Now, when you plug 0 in, you get 1 over 0. But the limit, they say, does exist. And I'll show you why. When you graph this one, you get 1 divided by x squared. And you graph it, and guess what the y values are doing on both sides? They're going to the same place. As you're getting closer to 0, your y value is approaching infinity from the left, and from the right side, your value is approaching infinity. So they say that the limit is infinity. I know, weird. Now the other one was different because it was going to negative infinity and infinity, so it's not like you choose one. It's not like there's two answers, plus or minus infinity. That one does not exist. Are you leaving for tennis? All right, good luck. Kevin used to play tennis. Yeah, he was really good. Okay, let's do this. Part B. Two-sided limits. Two-sided limits. Now, a lot of you, like you said, you'd rather solve these algebraically. Well, they're going to give you a graph, so you're not going to be able to solve it algebraically at all. It is. Two-sided limits. Now, I just kind of, talked about limits from the left and limits from the right and how different they are, okay? If you take the limit as x approaches c plus, the grade that you're getting in here, of f of x.
Who was that pointing to?
And this is equal to L.
Who was that?
I was just kidding. Just kidding.
We got the C plus.
No.
Come on.
All right. Or, wait a minute, here's the worst one. The limit as x goes to c minus of f of x equals L. Okay, the c plus and the c minus, what does this mean? Well, c plus means the right side of c. The right side of c. So as you're going from the right, so like for example, here's c, okay, and you know your rights and lefts. Right is over here, left is over here. And as you're going towards c from the right, then the limit would be over here. As you're going towards c from the left, you're looking at that one, okay? Now, as long as, and then this is the left side of c. As long as these are equal to each other, you will have a limit at c. Left side of c. Okay, so if these limits are equal, actually it's an if and only if statement, so it goes both ways. So, if and only if those limits are equal to each other, then the limit as x approaches c for f of x will equal L. Now, if they're not the same, then there is no limit at L. Okay? So, for example, if you have the limit as x goes to 3 from the right of f of x gave you a number of 5. And then you had the limit as x goes to 3 from the left of that function, and that gave you, say, 7. Then if they ask you what is the limit as x goes to 3, guess what you would say? Perfect. Does not exist. Okay? They have to be the same number. Because that would be a jump in the graph. If I was like from the left, I'm going up here, and here's 3, and I'm at 7. And then down here, on the right side, I'm at 5. Well, what's the limit? There is none. I'm approaching this and that at the same time. You can't do that. Okay, they have to go to the same spot. Okay. Oh, no.
How many letters are there?
No, this is it. Yeah, we're gonna do some examples now. Yeah. All right, so try to graph, what are we on, 2? Try to draw this graph as best you can, okay? Here we go. And then we're going to talk about this in depth. You're going to have one of these on your quiz. We're going to have a graph with a bunch of weird points on it and stuff like that. All right, so here we go. This is 2, and we'll go out to 4. And go ahead and put a dot at 1, at 0, 1. An open circle here at 1. 1, 2, 3. And then draw a dot here to an open circle here, all the way up to 3 here, and back down to 4. Okay, and then one last thing. Shush! Put a dot. Put a dot right there. Put a dot. Okay, try and copy that down as best as you can. You can do it. It's just dots and holes and lines. You're fine. Yours is super small? That's not my fault. Okay, are you ready? You got it? Okay, now I'm going to ask you a bunch of questions. It's going to have like A, B, C, D, E, F, G, all the way. So here we go. Let's start with, we're going to find the limit as x goes to 1 plus of f of x. By the way, this is the graph y equals f of x. We're going to find the limit as x goes to 1 plus of f of x. Ooh, very good. Okay, so go to where x equals 1. Okay, it's right here. X equals 1 is right here. Go to the left, the right of it, because that's plus. And as you're traveling towards the right, getting closer and closer to 1, then your limit is 1. It's the y value there. Okay?
If it was negative, then it would be 0. If it was 1 negative.
Yeah. Yep. We're going to do that one next. So the limit as x goes to 1 minus for f of x means that we're going to go to where x equals 1, right here, 1. Now we're going to go to just the left of it. So we're following our graph, getting closer and closer to 1 from the left, and our limit is approaching 0. What do you think my follow-up question is going to be? What's the limit as x goes to 1 of f of x?
Undefined.
Undefined, we usually write D and E for does not exist. The limit doesn't exist there. On one side I'm going to 1. On the other side I'm going to 0. Those do not equal each other. The limit does not exist. Okay, let's do some more. Yes. Let's find the limit as x goes to 2 plus, you do these 3. Shh. The limit as x goes to 2 minus, actually we're going to have 4. The limit as x goes to 2, okay, and one more, what is f of 2? Okay, let's see if you got this. If you can get this, then you pretty much have limits down. Like the graphical representation of them. Maybe not the algebraic ones, but. I'll give you a second to catch up and write those down. So now we're going to 2. 2's our graph here. All right, so take a look. For the first one, the limit as x goes to 2 plus. So that's to 2 from the right-hand side. My y value is getting closer and closer to 1. Good. Now from the left, 2 minus is this direction. As I'm getting closer and closer to 2 from the left, my y value is approaching 1. Since those are equal to one another, see they're both meeting here at 1. Like you're like, oh hey, let's meet at the movie theater. Okay, let's meet here and here. Let's meet up. So that means they're on a date. It equals 1. So, but what is f of 2? Perfect. F of 2 equals 2. See f of 2 on my graph? It's right here. It's this dot. And that is 2. Now, the other question is, if the limit is 1, does f of 2 have to equal 1? No, it doesn't. It doesn't have to equal it there. Okay? All right, let's do one last problem. And this one, you can use your calculator if you need to, or if you just know what it looks like. It's the graph called f of x equals INTX. Have you ever seen this before? You might have. This is called the greatest integer function.
Oh, it's that.
It is. It's weird. Some people call it the step function. Okay, what it is this. To find out what your number is, it's called the greatest integer. Integers, remember, are 0, 1, 2, 3, and they're negatives. Okay, so they're whole numbers plus the negatives, no fractions, nothing like that. So the greatest integer that's greater than or less than or equal to that number is where you're going to plot. So for example, if you were going to find out what the greatest integer of 0 is, it's 0. At 1/2, it's still 0. At 3/4, it's still 0.
Why wouldn't it be 1?
Because it's the greatest integer that's less than. It's like less than 1/2. Okay, at 1, guess what we do? We jump up. It's less than or equal to. That's really important. I should have said that. So all of these 1.2, 1.5, what's the greatest integer less than or equal to 1.5? It would be 1. All the way up until you get to 2. And then at 2, it jumps up because the greatest integer less than or equal to 2 is 2 itself. Then all the 2.5s and 2 points and all those, they all go to there until you go to 3. So people call it the step function. It's also called the greatest integer function. Your calculator has a button that will graph it too. So if you ever forget, and down here, it would be like the greatest integer less than -1/2 is -1, and then those all jump too. So it's like little steps. So if you go to your calculator and you want to find out how to graph this, go to y equals, and we're going to go to math, over to num. It's number 5, INT. Greatest integer of x, and then you graph it, and there it is. All those steps. Kind of fun, huh? Okay, so we're going to take the limit of this, because you know we get to, and it's fun. So here we go, letter A. What's the limit as x approaches 1 from the right of this greatest integer function? What's the limit as x approaches 1 from the right? So you go to 1, and 1 has a left side and a right side. The right side is here, the left side is here. So on the right, what is my y value getting closer and closer to? 1. Perfect. How about for the greatest integer function? 1 from the left. What's the limit as x approaches 1 on the left side of 1 for this function? 0. Okay, it's not equal to 0. There's a circle there, but it's getting closer and closer to 0 on my y-axis, like 0. And then what would the limit at 1 be? Does not exist. The limit as x approaches 1 does not exist. There's a big gap there. They can't be the same place. If I'm going on a date and I say, hey, date, meet me at the movies, and my date meets me at the restaurant, there's no date. Can't be 2 places at once. I know.